So our objective today is just to understand and calculate the discriminant. Of a quadratic function. Now, noticing that this comes off of the same page as we've been working at, it's still part of that same lesson. That lesson 13.4 had so much stuff in it. So much. So, let's give a definition to discriminant. So the discriminant is the expression b squared minus 4ac from the quadratic formula. Notice there is no square root symbol around it. It's simply the radicand. It's just the radicand. Now, what's interesting is the value we get. The value of the discriminant tells how many, and I'm going to give you three versions of the same word, right? How many x-intercepts / roots / solutions a quadratic equation has. So a lot of times when you're being asked to put a function together with its graph, and some graph crosses the x-axis twice, and some floats above it or floats below it, or some only touches down on the x-axis, you could eliminate some of those answers simply by doing the discriminant really quickly. Okay? So when I'm doing this, I have three potential answers. I have a positive answer, I get a negative answer, and then I have a third case, 0. And the reason why they have to single out 0 is because 0 is neither positive nor negative, so it doesn't meet the criteria of the other two cases. Now, without you leaving your answer this way, I want to give you some context for this number. Remember, this number is under a radical sign. Okay? So if I have a positive number under a radical sign, your answer is going to look something like this. A number plus or minus a number. How many x-intercepts, roots, solutions do I get in that instance? Say it out loud.
2.
I'm going to get 2 solutions. If I have this next scenario, where I have some number plus or minus the square root of a negative number, how many solutions do I have for this one? Why none? You can't take the square root of a negative, so there's none. Now in the third case, you would have a number plus or minus the square root of 0, which is the number. How many solutions is that? 1. What point? Or let's think about it this way. What kind of equation would you have that when you factored it and set the factors equal to 0 to figure out the x-intercepts, there was only one unique answer? You got the same answer twice. How does that happen? What kind of original quadratic equation did you have? so that you get one unique answer. Trent? This is the result of a trinomial square. What part of the parabola is intersecting the x-axis when I have one solution? The vertex. So the vertex is what intersects the x-axis. Okay? So again, this has a place of helping you kind of figure out things. It can give you already an idea of what your parabola is going to look like. It's going to tell you if it's floating well above the x-axis, pointing upwards, or if it's floating downward below the x-axis. It's going to tell you if it's crossing it twice, or it's going to tell you if it's just kissing it down by its vertex. And that's kind of the point behind it. So I'll just do an example real quickly of the three. So I am going to add one more note over here. And this, you'll probably find this funny. This is a floating, I call it a floater. Because a parabola that is a floater doesn't ever come in contact with the axis. So he floats either above or he floats below. So let's actually kind of explore what that one looks like. So let's say I give you y squared plus 3y plus 5 equals 0. Now, what do I need to have in order to use the quadratic formula? What has to be true about my equation in order to use the quadratic formula?
It's got to be in standard form.
If it's not in standard form, you're not ready to go. So that's just given, that if your equation isn't in standard form, make it so. Okay, is this one in standard form?
Yes.
Okay, so then we're going to identify A is 1, B is 3, C is 5. And now we're going to plug it just into the B squared minus 4AC. And we get 3 squared minus 4 times 1 times 5. And we get 9 minus 20 is negative 11. So if you notice, your quadratic coefficient is 1. So what direction is your parabola facing? Say again? Okay, it's facing upward. And if I did an axis of symmetry, remember that's x equals negative b over 2a. So that's negative 3 over 2 times 1, which is negative 3 halves. I can already give you an idea of what the parabola looks like. I don't have to be specific with it. I know that my axis of symmetry is at negative 1.5. And I know that my parabola is facing upward, and it does not come in contact with the x-axis. That's what I mean by a floater, is that it's floating above. It will never come in contact with the x-axis, ever. Okay? Now, is that the exact parabola?
No.
But again, I can get very quickly, I can come up with this, and I already have some ideas, so that when I have 4 graphs to choose from, I can eliminate anyone that's facing downward, and I can eliminate anyone that is actually touching the axis once or twice. So that's kind of the benefit about doing the discriminant. The one that we most likely are to see, because in most cases we are able to come up with 2 answers, would be something like this. So is it in standard form?
Yes.
So we just have A equals 2, B equals negative 1, C equals negative 3. And then we just plug it into the discriminant, which is just what comes underneath the radical. And we get negative 1 squared minus 4 times 2 times negative 3. And that gives me 1 plus 12 times 2 is 24, or I get 25. So what you're going to do is tell me what this number is, just like we did here. And then you're going to tell me that how many roots there are. So in this problem, there's no roots. In this one, it's positive. So that means it's going to be a pretty stereotypical parabola crossing the x-axis twice. Where? I don't know, because I haven't done the entire quadratic formula. Okay. And so this one is going to be somehow, let's see, it's opening upwards. So it's going to be something like that. I don't have to be any more accurate than that, to be honest with you. I could do axis of symmetry, which would be much closer to the y-axis because it would be 1/4. But again, what I notice is I'm going to get 2 roots because the answer is positive. Okay? So that's all you're doing with the discriminant, is helping you figure out how many times, not where, but how many times it's going to cross the x-axis.
How do you determine if the parabola faces upwards or downwards?
That would come from the project that you did.
Oh.
And you should notice that the A is what determines upwards and downwards. Okay? All right, that's it.